be maybe a little bit of review. And if not, we are going to take a look at this and hopefully go through and it'll make some sense. So it says blank. If you look at the I can statements first at the top, so I can define what a term is and a coefficient. We're going to go through that today. I can group parts of an expression differently in order to better interpret their meaning. Apply order of operations, and then inverse operations we'll be doing. And construct an argument to justify my solution process. Tomorrow you do have to, on the test, justify why those exponent rules work. So in this one, when we are taking a look, what we want to take a look is blank is a property that's used to simplify an expression. And that property is, if you're looking at that, the distributive property. So please fill in your notes, the distributive property is a mathematical property that's used to simplify expressions and equations. The next part that we are looking at is a term is one part of that expression. It's usually separated by addition and subtraction signs. So if I was looking over here at what a term is, I have an addition, a subtraction, another addition sign. This tells me that I have 4 terms, right? I have an addition, 2 additions, and a subtraction. I have 3 signs that I'm looking at, which means it separates 4 things. Terms that have the same variable raised to the same power are considered our like terms, which we will be able to combine together or add. And the last vocabulary that we are looking at on this page is a coefficient of a term. And what they say is a coefficient of a term is the number that is being multiplied by the variable. Not all terms have coefficients written in front of them. If there is no coefficient that is written, it is a 1. So when you are thinking about, if I have just x, it is understood that that is 1x. It's always understood that there's a 1 in front of a variable. Okay? So, writing that example there. When we talk about like terms would be like if I'm looking at 4x squared and x squared. Those are considered like terms. They both have x to the second power. Okay, the same variable to the power. And then we are going to work with distributive property, which when we do that, it's a way of eliminating our parentheses. So an example of distributive property they have written here. Distributive property, it's kind of like at the beginning of this unit when I distributed your notes and workbooks, is that I'm starting at the front of each row and I'm taking, in this case, I handed it out to each row. You're going to take the 3, so right above this, please write 3 times 2x plus the 3 times 7. So when we start our homework today with distributive property, I'm going to ask you to write the problem. Then I'll have you put this step, and then I will have you put this part as your answer as we look at that. So we're going to practice some distributive property. So when we are doing our homework in the same way, we are going to take, so we are going to write 2 times 1y. If it helps you to put 1y, someone said, can I just put 2 times y? You could. Sometimes these arrows seem to help students to make sure they remember that they have to take 2 times the 4 also. I don't care if you use a dot or if you use parentheses, either one would work for me. And our answer here would be 2y plus 8. Are these like terms? Can I combine them together and make this 10? I can't make it 10y, I can't make it 10. It's kind of like me saying, you know what? I'm going to add all these, the x's are my scissors, and the y's in this case, since there's, or the numbers are the glue. I cannot make them into a gluing scissors, right? I can't combine them together. These are 2 separate things. I can't combine them together. So when we look at these, that will be our final solution. So let's go to the next one. And we are taking 12. And again, I don't care if you use 12 times 3. Since there's a minus sign in the original problem, we're going to keep that minus. And then we're going to take 12 times 1/6 h. Now, 12 times 3 gives us our 36. But when we're looking here, we might want to think of this as 12 over 1. And so if I'm looking at that as 12 over 1, I want to actually simplify before I multiply. I mean, I could put 12 over 6, but 6 goes into both 12 and 6. 6 goes into 12 2 times and into 6 once. So I really have, if I'm looking at this, 2 times 1 times h all over 1, which is simply 2h. So the next one, the 3 is behind. Does it matter if that 3 is behind or out in front to use the distributive property? It does not matter. So please take 3 times each thing in your parentheses. So we are going to write that as 3 times 0.4 plus 3 times 1.1z. Now I know that 3 times 4 is 12. So 3 times 0.4 should be 1.2. And if I am looking at multiplying here, I should have plus 3.3z. If I asked you, going back to this first one, how many terms do we have? How many terms in this answer? 2 of them, right? They're separated by an addition sign. And if I asked you, what is the coefficient, so please add this in your notes, the coefficient of y. What is the coefficient of y? That means the number that's times y, which in this case should be 2. So again, over here, please tell me the number of terms and then the coefficient of h is what we're going to be looking at. Again, here I want you to tell me the coefficient of z and how many terms. Please check with your shoulder partner on the number of terms and what the coefficient of h is, and this part for z. Do that right now. And then we're going to look at that last example. What? Hang on. Terms are separated by addition or subtraction. So if I'm looking at terms, all the answers up to this point had how many terms? 2 terms, right? This term, the coefficient for z, happens to be 3.3, because that's what is times z. Okay? This is the one that's a little trickier. And the most common answer I will have is 2. And that is wrong. The coefficient of h, you have to have the sign with it. And because this is 36 minus 2h, and really subtraction, remember, can always be rewritten as 36 plus a negative 2h. The coefficient is negative 2. So you have to keep the sign with it. Anyone have negative 2? Okay, so just being aware of that. All right, so let's do this last one. We're going to multiply. We're taking 1/5 times each thing. So we're taking 1/5 times 5x. And as you do your homework, yes, I want you to write that 1/5 as we do the homework tonight. Once we get into this unit and you're getting really good at distributive property and I don't have to worry about that, then you don't have to do that anymore. But most of you, you're going to start today showing you this. If I have 5x divided by 5, that is really 1x, right? And if I have 15 divided by 5, I'm really looking at minusing 3, because this would be 3 over 1. So again, we have in this answer, we have 2 terms my coefficient of x is equal to 1, and I have a constant. My constant is the number that is all by itself. The number that is by itself in this case would actually be -3. The constant over here in this one, if I was looking for the constant is just the number, would be 1.2, okay? So the constant is simply the number. The word coefficient is the number that's times the variable, okay? So we kind of start with a lot of vocabulary as we're looking at this with distributive property, okay? Let's turn to your next page in your notes. And in your homework, you're going to see a problem like this. Now, this homework that you're getting today in your workbook is not due until Thursday, okay? Tonight, you should be studying for your test, okay? So, as you are taking a look, and we're going to simplify this. It says to simplify each expression, we're going to divide every term on the top by the number in the denominator or the bottom. So, please write this as 3x divided by 5 plus 10 divided by 5. We can't simplify 3x over 5. That is in its simplest form. But the 10 over 5, we can simplify. So we are going to rewrite this as 3/5 x. And really this x could be in the numerator or it could be right behind this, plus 2 as our final answer. Do the same thing with this next one. We're going to rewrite it as 15 over 7. It's going to be a plus. We're usually going to always keep the variable in the numerator, so 6m divided by 7. Can anything be simplified here? Is there a number that goes into numerator, denominator, or both those? No. And someone said, oh, I could write that 15 over 7 is a mixed number, yes, or as a decimal, but we're going to just keep them as an improper fraction, okay? The other thing that we're going to look at today before we get into more with our terms and like terms is multiplying by -1. So when you see multiplication by a -1, any number except 0 multiplied by -1 will always become its opposite. So when you look at this and you kind of see those 3 examples that we have going across, -1 times -5 is 5. It just makes it turn into the opposite of that number. So if I have -1 times 2x plus y, if I'm looking at the opposite of that, this is what we're really thinking of doing. We are taking -1, I want you to write this down. We don't always have to have this. We're taking -1 times 2x, right, plus -1 times y. Write this, please. Some of you aren't writing anything. I need to see your pencils moving. So, if we are looking at this, the opposite of 2x is -2x. The opposite of y is -y. Now, sometimes it's better to put this as plus a -y. And again, I'm looking at this and I have 2 terms in my answer, right? I cannot combine these. These are not like terms. They're not the same variable. If I was looking at the coefficients, okay, the coefficient of x is -2. The coefficient of y is a -1. So for some of you, if you like putting this -1 in here, I will never mark that wrong. But if you want to just put -2x minus y, that would be correct also. Okay, so I just want you to be aware that both these answers would be right. So again, this is going to change everything to the opposite. So if I'm looking at the opposite of -3, opposite of -3, I'm going to be looking at Braden as what? 3. And Lizzie, if I'm looking at the opposite of -4u, so it's going to be 4. So I'm going to have 3 plus 4u, right? This out in front is telling us to take the opposite of whatever is inside of here, okay? Again, 2 terms in our answer that we are looking at. 3 is the constant. So if we were looking at that, 3 is our constant term. We have 2 terms in our answer, okay? So it's very likely that on Thursday, like a small homework quiz on some of the vocabulary part of this, okay? So now we're looking at the like terms. So example of like terms and unlike terms. 7a and negative 3a. Their variable factor is a. Would you say those look alike or not? As we are looking at those. They should be alike, yes. If we are looking at 4x squared and 12x squared, they both have x squared. Are they like? Yes. We look at the next one, and we are talking about 6. We have AB and A for ours. Are they like terms? How about this last one? XY squared, x squared, y. No. They have to be exactly the same. If I had xy squared and xy squared, those would be like, but these ones are not. Okay, so you just got to be careful. They have to look exactly the same. So you got to be really careful. You got to be really precise when you are looking at these. All right. So the simplified expression. Simplified expression means kind of like in our last unit when we did exponents, you couldn't have negatives. This means no like terms, no parentheses. Okay? It says like terms that have the same variable are part of this. It's kind of like your same last name, but differ only in their numerical coefficients. So what we are going to do is I want you to write it like this. We're going to take 3, and this would be minus what numbers in front of y? 1. So 3 minus 1, and then put a y behind that. 3 minus 1, Bo, gives us 3 minus 1 gives us 2. And then we put our variable, which was y. Someone said, well, why don't we put y squared? Remember, you would put y squared if you were multiplying these two together. That's when we add our exponents, only when you multiply. So here you would have had 3, and you would have had y to the 1 plus 1. That would have given us 3y squared. We are not multiplying these. We are adding, and we add the coefficients, and the variable stays the same. So again, we're going to kind of look at this next one. We have like terms. So we're going to think, oh, I have to take negative 7. And I know it's a minus 5. We're going to change that mn to the 4th. We're going to change this subtraction to adding the opposite, because many of you are still making mistakes with your integers. Meaning, if I have a negative 7 plus negative 5, they're both negatives. It should be a bigger negative number, like further down. It's actually a smaller number, but we're going to add the 5 and 7. When we add 5 and 7, Wyatt, I'm going to end up with? Negative 12, and then I'm going to put m and n to the 4th. Well, then all of a sudden in your homework, they kind of start with some simple ones with either distributive property and adding like terms, and then they start combining and doing a couple of different things. So if I'm looking at this problem and I have 3 times x squared, and again, putting these arrows or showing, as you're showing your work, either below or above the problem as you're looking at that. So I have 3 times x squared, plus I have to have 3 times 2, plus I have to have 2x squared. At this point, I have 3 terms, right? I have 2 additions, I have 3 terms, okay? I want to simplify it down. These are my like terms. Now, sometimes people like to underline, sometimes they'll put a square around them. I have some students that like to use their highlighter and say, okay, if I'm combining these two together, 3 plus 2 gives us 5x squared, right? Because we're adding the 3 plus the 2, and that's with our x squared. And then 3 times 2 is 6, so I have 5x squared plus 6, okay? Some of you will write it this way. Can you just go from this step to right here? Yes. The last one. Do we have like terms? Can we combine them together? No. So my answer, if I ask you to simplify it, is the same thing. It is 3w plus 5w squared. We cannot simplify this. It is already simplified. Okay, we cannot simplify. That is simplest form. Okay. Questions on anything as you are looking at this? Okay, kind of a change of pace from all those exponent and scientific notation. Okay. Some of you will be happy, some of you won't. Now, these are the kind of questions that you did last year, where you did the one and some two-step, like in those practice questions at the beginning. First thing it says is identify the operation in the problem and identify the inverse. So in our problem, it's telling us to take G and do what operation as I look at that, Carmen? We're supposed to what? Subtract. So our operation in the problem, so please put the operation in the problem, write this right behind, is subtraction. Okay? We need to find the inverse of that. So the inverse of subtraction is to do what, Ava? Add. Inverse of subtraction is going to be to add. So what I need to see, because on our standard, and I haven't put our poster up because I'm waiting to put this one down, but on my test for this one, I have to see the inverse operation. I need to see that you understand that we can add 3 to both sides of this equal sign and keep it balanced. Now I will have people go, oh, I know the answer to this. That's fine. So we're going to take G. Since we have a negative 12 plus 3, the signs are opposite with integers. We actually are not adding those. We're going to subtract. And 12 minus 3 gives us 9. And in this case, we're going to put negative 9. And if I check this, anyone know how to check an equation? You're going to do that? To check, you need to go back to the original, okay? So please write this down so that if I ask you again, you're like, I don't get it. To check it, go back to the original, and you're going to replace the letter. In this case, we're going to replace the G with negative 9. So for my check, I'm going to write this equation, G minus 3, and it's supposed to equal negative 12. So I'm going to put in, and I might use my calculator, put negative 9 minus 3. And the question is, does that equal, so put that in your calculator, does it equal negative 3 minus 12? Some people, if they're doing it in their heads, might want to think negative 9 plus negative 3, and does that equal negative 12? Yeah. So we did it right. This is our answer, okay? Now, the reason that it's important that you do that check is because when you look at the problems that are on the front of your notes or your workbook, this is what it's going to look like towards the end. You're going to get a problem that looks kind of like this one. And when you get something like this, you definitely want to do the check. Now, these simple ones that are kind of one-step problems, they're not that hard. But when we get into things that are 2 and 3 steps and variables both sides, you want to know how to do the check. So, as we continue with this one, what operation are we looking at, Brett, in the second problem? The operation is when you have 4 next to m. What operation? Multiplication. So, if we are looking in the original problem, the operation is multiplied. So, my inverse, the opposite of that, Sophie, is going to be division. So we want to divide. Now, I know some of you how you show your division, and I'm going to ask that you show it this way. This line simply means division. The question is, should I divide by 4 or should I divide by negative 6? You always want to divide by your coefficient. The coefficient of m is 4. You want to divide both sides by 4. 4 over 4 on this side leaves us just with m. I like putting my equal behind the variable, so I put m equals. And I have negative 6 over 4. If you leave negative 6 over 4, I have to take off a point. This can be simplified to negative 3 over 2. Someone said, well, can I write it as negative 1.5 as a mixed number? Yes. I would take that as an answer. I would also take negative 1.5. Okay? But if you leave it as negative 6 over 4, you're going to lose a point on that. Okay? So, again, we're going to get into the 2-step, and that's kind of what that one that you had in class was. And then we're going to have some time to work here. So, as you take a look at this, We actually have two operations, so two steps. First thing you have to do, you need to get 3n by itself. Your first goal, get 3n by itself. So I have 3n plus 2. Layla, if I want to get rid of the plus 2, what's my inverse operation? Subtract. So I am going to, right below this, please write this, minus 2, minus 2. You have to keep your equal sign balanced. Sometimes I have students that like to draw this line going down to show both sides. Whatever you do on one side of the line, you do it on the other. I don't care if you do that. I know Mr. Rock does that a lot when he taught this unit. Okay, so I'm left on this side with 3n, because 2 minus 2 is 0. And on this side, am I going to have negative 7 or negative 5? Or negative 3? Negative 7 or negative 3? And again, here's where subtraction, you can rewrite it as plus a negative. Negative 5 plus a negative 2 is actually going to give us negative 7. Sage, what operation is happening with the 3 and n? What is it? Multiplication. So I want to now get the n by itself. Okay, so remember, our goal is getting the variable totally by itself, but in this case I want that n by itself. Since I have 3 times n, the inverse is to, instead of multiply by 3, divide by 3. You get kind of an ugly answer. Negative 7 over 3. These 3's cancel. If you like writing one n, you can, but you can just put n equals. You can leave it as negative 7 over 3. You could leave it as, if you wanted to change it to a mixed number, you could do that. We probably aren't going to change it to a decimal as we started the problem. Some of you prefer decimals. If you were looking at that, that would be negative 2 and 1/3. Or negative 2.3 repeating. If you only put 0.3, I'd have to mark it wrong, right? 0.3 repeating. So let's go to the next one. As we are looking, Connor, at that next one, I need to get this k divided by 2 by itself. What are you going to do to get rid of the minus 5? So I have what operation with the 5? That's telling us to do what? But this one is telling us to do subtract. So the inverse of subtracting 5 is to add 5. So we're going to put a plus 5 both sides of the equal sign. Once I've done that, Grace, I have negative 7 plus 5. I'm going to end up with what?
Negative 12.
Careful.
Wait, no, we subtract.
We do subtract.
So, 2.
Negative 2. So, because the signs are opposite, we have to subtract. We are still left with this k divided by 2. My goal, okay, so our goal now is to get k by itself. It is k divided by 2. The opposite of divided by 2 is to, Haley, do what? Multiply. And we're going to show it just like this. We're going to show multiplying by 2. And I'm actually going to put 2 over 1. But on this side, I'm just going to put 2. The reason I don't want to put it over 1 on this side is I don't have a fraction that I'm dealing with. So 2 times negative 2 gives me a negative 4. And on this side, I would have canceled it out and been left with 1k. If you don't show the inverse operations, you will not get credit for this assignment, and I will give you a redo and ask you to do it over, okay? So, as you are looking at these problems, the first 2 are 1 step, the second 2 are 2 steps. I would like you to try those. We are going to put those up. The first step, I got to get 4h by itself. Opposite of minusing 3 is to add 3. H equals 18. It is not going to be a nice number. It's going to be a fraction or a decimal. Chloe, since I have 4 times h, the opposite of multiplying by 4 is to divide. This line means division. So we are just writing that each one over 4. So if I'm looking at that, 18 over 4 can be simplified. 2 goes into both of those, right? So 18 over 4 could be actually 9 over 2. I would take 9 over 2. I would take 4 1/2. I would take 4.5. That makes sense? I'm starting this one out.
How'd you get 18?
How did I get 18?
Yeah.
15 plus 3. Opposite of subtracting 3, but 15 plus 3 gives us 18. Okay. Ellie's starting the next one. I want to get this m divided by 2 by itself. We're going to do what?
Subtract 8.
Subtract 8. We subtract 8 on both sides, and I'm left with m divided by 2. Equals 5 plus -8 gives us a -3. We're trying to say what number divided by 2 equals -3. Well, the opposite of dividing by -2 is actually going to be, or divided by 2 is to multiply. We're going to put that parenthesis of times 2. The 2's cancel here, and we're left with m equals -6. Okay? So this should kind of be review that you did last year, okay, as we start this. So, the worksheet D1 that is in your workbook is not due till Thursday. Tonight, study for your test. Make sure you are ready